within the eye wall and the rain band. And for the upper level, we can see a lot of the radial outflow. And so if we take AB cross section in the cross-track attraction, we can see a typical tilting of the eye wall, and also we can see some rain band behind here. And this one is the contour field. The color field is for the cloud ice and the cloud water, so we can see a lot of cloud ice and especially the supercool liquid water in the eye wall, and some ice field also in the rain band here. And then if we look at the contour field here is for the strong relative radial wind, so we can see a strong convergence, strong inflow in the low level and outflows in the upper levels. And because when the Nari is over ocean, is quite symmetric, so we take a 1 hour and the azimuthal average of the structures. So we can see in the upper panel, this shows the condensation and the deposition. So we see a lot of condensation in the eye wall, and also some condensation deposition in the outer rain band region here. And for the evaporation and sublimation, again, we can see a lot of evaporation of falling raindrops. And here, this is for the typical rainfall outturn. We can see a lot of rainfall in the eye wall region, and also some rainfall produced by the melting of the falling graupels. And then this is show the water vapor horizontal flux divergence, and this one is the vertical flux divergence. And we can see these two are relatively out of phase with each other because the airflow is quasi-incompressible in the general sense. And this one is for the liquid and ice field for the horizontal flux divergence and the vertical flux divergence. Again, these two are relatively speaking out of phase with each other, but more structure we can see in the upper region of the eye wall. So we do a Barren integral vapor budget and the liquid and ice water budget in the inner region and the outer rain band region. Inner region we define with radius of 50 km, outer rain band region defined as the radius between 50 and 150 km radius. So one thing we want to draw your attention is that for the BBL is the flux over the ocean surface. Here is only a very small portion, 1.4 relative to the horizontal transport is less than 10%. For the outer rain band region is a little bit stronger, but still much less compared to the horizontal transport from the outer region. And then for the precipitation water budget, we can see that for the Nari case, we can see that there are more rainfall in terms of Barren integral falling over the outer rain band region compared to the inner core regions. However, after the making rainfall then the structure is quite different. We can see that this is a 1 hour average radar reflectivity field after the Nari making rainfall over the northern Taiwan. So if we take this kind of AB cross section in the north, in the along track correction, and also the south, also the cross track correction, we can see a different structure. In this northeast AB cross section, we can see especially over here, we can see the convection is more upright in the oceanic branch, but convection is much weaker and spread out a wider region in the overall region of sustained terrain. And for the CD track, the structure is more more and less symmetric with each other compared to the landfall stage. And then we also see a horizontal cross section in 4 different levels. This is low, right near the surface at the sigma 0.9985, and this one's near this one in the low level. This one's in the middle upper level. This one's upper level. Again, we can see most of small-scale convergence and divergence associated with mountain flow over the valley and the peak of the central mountain range. And then if we first look at first we look at this kind of AB cross section cutting through the big mountain of mountain snow in northern Taiwan. We can see the precipitation is more widespread over the region of mountain snow compared to here the rain eye wall is more upright. And then we can see for the cloud water and the liquid and the cloud ice field, we can see over the region of mountain snow, there are a lot of waters and the clouds here. But over the ocean part, you can see the cloud ice and the cloud water in the upper levels. So if we look at the VR, the radial velocity field, in particular we can see for the ocean part, it remains a similar structure as the oceanic average one. However, for the land branch, we can see a sloping outflow jet right above the terrain, and this one will play some important role to transport hydrometeor from the inner core to the outer rain band, so that the precipitation area is much wider in this region compared to this region. And then this one is another cross section. This is in the CD cross section. So CD cross section, the terrain is much less. The terrain height is much less. So the terrain effect is quite different. So any asymmetric structure in this cross section will be mainly due to the stone dynamic itself. And again, we can see that more or less we can see the outflow in the inflow in the low level and the outflow in the upper levels. And then we would like to compare the difference of the microphysics exchange rate. So upper panel is for the result of the oceanic stage. The lower panel is the result for the landfall stage. And again, this one is for the evaporation and the condensation, and this panel is for the condensation and the deposition. So if we look at the condensation deposition field again, we can see that after the landfall of the Typhoon Nari over Taiwan, we can see a lot of condensation, especially on the windward side, on the on the southwest side of the eye. And then there are also some reduced conduction associated with the mountain valley and the hills. And for the evaporation and sublimation, we can see after the landfall again, we can see a more enhanced value associated with the flow over the mountains. And by the way, these are all volume integrated result, and also in the 1 hour average result. And then if we look at these two cross sections, we can see that over the region of the substantial peak, we can see a lot of condensation over the mountain area. And then if we for over the ocean region, the condensation is maximized at a higher level compared to this one is maximized at the lower level.